So today we want to study how to calculate the molar mass and how to solve the various problems that are related to the mole concept. So let's first start with the calculation of the molar mass. So though we have discussed all this, let us discuss once again. Calculate the molecular mass for these various, these are your in-text questions even, my dear students. Calculate the molecular mass of hydrogen, oxygen, chlorine molecule, carbon dioxide molecule, methane molecule, ethane molecule, ethene molecule, ammonia molecule, and ethanol molecule. Let's move forward. Now, the information given is atomic mass H is equal to, for hydrogen it is 1 gram per mole, for oxygen it is 16 gram per mole, for chlorine it is 35.5 gram per mole, for carbon it is 12 gram per mole, and for nitrogen it is 14 gram per mole. So when we want to calculate the molecular mass for H2, molecular mass of H2 is equal to 2 into atomic mass of hydrogen. Atomic mass of hydrogen is 1 gram per mole, my dear students. So for this value, we just put 1 gram per mole, and that is why the molecular mass of H2 is 2 gram per mole. Same way for O2, we can write molecular mass is equal to 2 into atomic mass of oxygen. Atomic mass of oxygen is 16 gram per mole, and that is why 16 multiplied by 2, that is 32 gram per mole, is the molecular mass for O2. This is what we can easily understand. Let's move forward. Now we want to calculate the molecular mass for chlorine. So chlorine is diatomic molecule. So we can easily write that the molecular mass of Cl2 is equal to 2 into atomic mass of chlorine. Atomic mass of chlorine is 35.5 gram per mole, and that is why 35.5 multiplied by 2 gives us 71 gram per mole. Next, my dear students, we want to calculate the molecular mass for carbon dioxide. For carbon dioxide, we can see that in carbon dioxide molecule, there is one carbon atom and two oxygen atom. Therefore, the molecular mass of carbon dioxide molecule is equal to 1 into atomic mass of carbon plus 2 into atomic mass of oxygen. Atomic mass of carbon is 12 gram per mole, my dear students, and the atomic mass of oxygen is 16 gram per mole. So 12 into 1 gives us 12, 16 multiplied by 2 gives us 32, and finally by adding 12 and 32 we get 44 gram per mole, which is the molecular mass of carbon dioxide. Same way, my dear students, we want to understand it for methane. In the molecule of methane, you can see from the formula that it has one carbon atom and four hydrogen atoms. So molecular mass of methane is equal to 1 into atomic mass of carbon atom plus 4 into atomic mass of hydrogen atom. The atomic mass of hydrogen atom is 1 gram per mole. The atomic mass of carbon is 12 gram per mole. And by multiplying 12 with 1, we get 12. By multiplying 4 with 1, we get 4. And finally, we get 12 plus 4, that is 16. So the molecular mass of methane is equal to 16 gram per mole. This is how, my dear students, we understand the calculation of the molecular mass for methane. Now we want to calculate the molecular mass for ethane. We can see from the formula that in ethane we have 2 atoms of carbon and 6 atoms of hydrogen. Therefore, the molecular mass of ethane is equal to 2 into atomic mass of carbon plus 6 into atomic mass of hydrogen. The atomic mass of hydrogen is 1. The atomic mass of carbon is 12, and that is why we put the value for C we put 12, for H we put 1. 2 into 12 plus 6 into 1. 12 2s are 24 and 6 1s are 6. And by adding 24 and 6 we get 30. So for ethane C2H6, the molecular mass is 30 gram per mole. Now we want to calculate the molecular mass for ethene, that is C2H4. The molecular mass of ethene is equal to the 2 into atomic mass of carbon and 4 into atomic mass of hydrogen. The atomic mass of carbon is 12 and the atomic mass of hydrogen is 1. So by putting this value for C, we put 12, for hydrogen we put 1, and ultimately we find 2 into 12 and 4 into 1. 12 2s are 24 and 4 1s are 4. So finally 24 plus 4 gives us 28 gram per mole. And this is how, my dear students, we can understand the molecular mass for ethene is 28 gram per mole. It's very easy for us to understand. I'm giving you enough of practice so that you can understand it well. Now for NH3, you can see that in the molecule of NH3, we have one nitrogen atom and three hydrogen atom. So we can so we can write 1 into atomic mass of nitrogen and 3 into atomic mass of hydrogen. Atomic mass of nitrogen is 14 gram per mole and atomic mass of hydrogen is 1 gram per mole. So by putting the value, instead of n we put 14 and instead of h we put 1. Finally 14 ones are 14 and 3 ones are 3. So 14 plus 3 is equal to 17 gram per mole is the molecular mass for the ammonia NH3. Here we are given the formula CH3OH. It is known as the methanol, my dear students. It is nothing but your methanol. This methanol has one carbon, three hydrogen, one oxygen, one hydrogen. So for that we can easily write one carbon, 1 into atomic mass of carbon. For calculating the molecular mass, we can write 1 into atomic mass of carbon, 3 into atomic mass of hydrogen, 1 into atomic mass of oxygen, and 1 into atomic mass of hydrogen. We know that the atomic mass of carbon is 12, so we can easily put 12 for this. Same way for hydrogen, the atomic mass is 1. So wherever we have hydrogen, we put 1, and the atomic mass of oxygen is 16 gram per mole. So when we put all these values, we get 1 into 12 plus 3 into 1 plus 1 into 16 plus 1 into 1. 1 into 1, 1. 1 into 16, 16. 3 into 1, 3. And 12 into 1, 12. So we have 12 plus 3 plus 16 plus 1. 12 plus 3 gives us 15. And 16 plus 1 gives us 17. 15 plus 17, we get 32 gram per mole. And this is how, my dear students, we can find out the molecular mass for methanol, that is 32 gram per mole. Here a very important instruction for you, my dear students, that at the end of the calculations, it is necessary to write the unit for the answers. Please remember that whenever you do such calculations, it is necessary that you need to write the unit for the answers. When you calculate the molar mass, you generally write the unit gram per mole for your answers. So please do not forget. Now, my dear students, we want to understand how to calculate the formula unit mass. So my dear students, whenever we have ionic compounds, these ionic compounds, they do not have the molecular mass, but instead of that, they have the formula unit mass. So let us calculate, or let us understand how to calculate the formula unit mass. The formula unit mass, if we define, we can say that formula unit mass is the sum of the atomic masses of the all the atoms present into the ionic compound. Once again, what is the definition of formula unit mass? Formula unit mass is the sum of the atomic mass of all the elements present into the ionic compound. That is what it is, the definition for the formula unit mass. Let us calculate the formula unit mass for the various compounds. Let us start with the zinc oxide. So here you can see that for zinc oxide, we can see into the formula that in zinc oxide we have one zinc and one O. So we can write 1 into Zn plus 1 into O. Now you can see in the question itself that they have given us the value for the atomic mass of zinc, that is 65 U. So we will even write 65 for zinc, and for oxygen it is 16. So we will write 16 for oxygen. So 65 plus 1 gives us 65. 16 plus 1 16 into 1 gives us 16, and by adding 65 and 16 we get 81. Here, instead of writing the gram per mole, my dear students, as in the question the unit is given U, we will write also U, which means the unified mass. So this is how we calculate. Same way, same as the molecular mass, the formula unit mass is also calculated. Just the compound which are ionic in nature, we calculate the formula unit mass for them. Now for Na2O, my dear students, we can, for calculating the formula unit mass, we write 2 into atomic mass of Na plus 1 into atomic mass of O, because only 1 is present, whereas sodium atoms are present 2 in number. Now we know that the atomic mass of sodium, is 23 U. So we will put 23 instead of sodium or Na. So we put 23 for Na and 16 for oxygen. And thus 23 multiplied by 2 gives us 46, and 1 multiplied by 16 gives us 16. So finally we get 62 as a formula unit mass for our Na2ISO, that is sodium oxide. Now we want to calculate for K2CO3, my dear students. If you look into the questions for K, they have given 39U. For C, they have written 12. And for oxygen, they have written 16U. So looking into the formula, we can say that there are 2 K atoms, 1 carbon atom and 3 oxygen atoms. So formula unit mass is equal to 2 into the atomic mass of K plus 1 into the atomic mass of C plus 3 into the atomic mass of O. For K, we can write 39 because the atomic mass for potassium is given 39, for carbon it is given 12, and for oxygen it is given 16. So 39 multiplied by 2 gives us 78, 12 into 1 gives us 12, 16 multiplied by 3 gives us 48, and by doing the sum of 78, 12 and 48, we get 138U. So my dear students, sorry, same as the molecular mass, we can even calculate the formula unit mass, just the word changes. And as in the question, the atomic masses are given in the unit unified mass U. So for all these questions, we have even written the unit as unified mass U. Now, again, a very important instructions for you, my dear students, that it is necessary to write the unit after the calculation. So whenever you finishes your calculation, please do not forget to write this unit after the calculation, whether it is the calculation of the unified mass, whether it is the calculation of the formula unit mass, or it is the calculation of the molecular mass. Please even note that here the unit U, what we write here, it means the unified mass. Now let's move forward and understand the other part of this. Now we want to study about the new concept which is known as the mole concept. So here we understand about the moles. My dear students, there was a scientist, his name was Avogadro, Amido Avogadro. He said that this scientist Amido Avogadro says that for any 1 mole of substance, for any 1 mole of substance, my dear students, we have 6.022 into 10 to the power 23 species. Either it may be the atoms or molecules are present. So my dear students, using this idea, we can calculate so many things. Like for atoms, we have the atomic mass, and for molecules, we have molecular mass. We can, if we are given the mass in gram, my dear students, so from mass in gram, by multiplying or by dividing the mass in gram with atomic mass for atoms, and by dividing the mass in gram by molecular mass for molecules, we can calculate the number of moles. And from this number of moles, we can multiply this number of moles with the Avogadro number Na to get the number of atoms or number of molecules or number of ions. Same way, if we are given the number of species, that may be the number of atoms or number of molecules or number of ions, then dividing them with the Avogadro number Na, you can see here I have even made arrow and show you that it is the division part. So by dividing it with the atomic Avogadro number, we get number of moles, and when this number of moles is multiplied with atomic mass for atoms, and if it is multiplied with the molecular mass for molecules, we get mass in gram. So here in 9th standard, we will study the mole concept problems, and in these mole concept problems, my dear students, we will study how we can convert the number of species into number of moles, and number of moles into the mass in gram, or mass in gram to the number of moles and number of moles to the number of species, or directly from mass in gram to the number of species, or from number of species to the mass in gram. So let us understand how can we do it with the examples, and let us solve the various problems given in your textbook and exercise. Let's start with the first question. Calculate the mass of 0.5 moles of nitrogen gas. Atomic mass of nitrogen is 14. So nitrogen gas, that is N2, which is a diatomic molecule. So molecular mass is equal to 2 into atomic mass of nitrogen. Atomic mass of nitrogen is 14, so 2 into 14, that gives us 28 gram per mole. So number of mole is given, that is 0.5 mole. Molecular mass is 28 gram per mole. So now to calculate the mass in gram from moles, you can see here I have given you an arrow. We are given moles, moles are already given. We want to calculate the mass in gram, so we will have to go from number of moles to the mass in gram. So we will have to take this path. How can we do it? Here we are given the molecules. So we will have to use the molecular mass. So my dear students, we can use the molecular mass. So the number of moles, if they are multiplied with the molecular mass, we will find the exact answer. So when this number of moles are multiplied with the molecular mass, we will get mass in gram. And therefore, to calculate the mass in gram from moles, mass in gram is equal to number of moles multiplied by molecular mass. Number of mole is 0.5, molecular mass is 28, and by multiplying 0.5 with 28, we get 14 gram. And this is how, my dear students, we get the answer for this question. Now let's move and understand the next question. Calculate the number of atoms, 0.5 mole of n atom. So here instead of the molecules, my dear students, we are given the number of atoms. So going from moles to the number of atoms, the number of moles is 0.5. The Avogadro number is given as a Na, that is 6.022 into 10 to the power 23. Number of n atoms is equal to moles multiplied by Na. So we are going in this direction, moles to the number of atoms. So as we are going from moles to the number of atoms, we just need to multiply them with the Avogadro number. So number of n atoms is equal to moles multiplied by Avogadro number. Mole is 0.5 and Avogadro number is 6.022 multiplied by 10 to the power 23. Multiplying 0.5 with 6.022, we get 3.011 and 10 to the power 23 as usual. So we will have 3.011 into 10 to the power 23 nitrogen atoms. Now, my dear students, we have the next questions. Let's look at the next questions for you. Let us read what is the question for you. Here we can see easily that we want to calculate something very interesting here. Let's see. We want to calculate the mass from the mole of the molecules. Atomic mass for nitrogen is given as 14 gram per mole. Now we need to calculate the mass of 0.5 mole of nitrogen atoms. So mass is equal to number of moles multiplied by atomic mass. Mass is equal to, mass is nothing but mass in gram. So mass in gram is equal to number of moles multiplied by atomic mass, because atoms are given here. That is what we can easily see here. My dear students, that if we want to go from number of moles to the mass in gram, if we want to go from number of moles to the mass in gram, and if the atoms are given, we need to multiply it with the atomic mass. So mass in gram is equal to number of moles multiplied by atomic mass. This is how we get the formula. So you can see here, I have written the formula for you, that mass is equal to number of moles multiplied by atomic mass. Number of moles is 0.5 and atomic mass is 14 gram per mole. So by using this, we can 0.5 multiplied by 14, that is what it is, 7 gram. So this is how, my dear students, we understand the various calculations for our problems. Now we want to understand the finding moles from mass. How to calculate finding moles from mass. Let us understand how to calculate finding moles from mass. Calculate the number of moles for the 52 gram of helium. So here we are given the 52 gram of helium. That is what it is, the mass in gram for helium. And we want to calculate the number of moles. So we are given mass in gram and we want to calculate the number of moles. If we want to calculate the number of moles from the mass in gram, we need to divide by the atomic mass. Atomic mass of helium is 4 gram per mole. Mass in gram is given as 52 gram. So 52 gram, if we divide with the 4, we will get the number of moles. And that is why we write number of moles is equal to mass in gram divided by atomic mass. Mass in gram is 52 gram, atomic mass is 4 gram per mole. This 52 is nothing but 13 multiplied by 4 divided by 4. So finally we get 13 gram per mole, and thus the sorry, I have made a mistake. 13, not gram per mole, my dear students, but it is 13 mole. That is what we can say, that 52 gram of helium is 13 mole. And this is how, my dear students, we get 13 mole as an answer. Same way, my dear students, we want to find out the mole from the number of particles. So we want to find out the moles from the number of particles. That means we are given number of species or number of atoms. How many? Calculate the number of moles from 12.044 into 10 to the power 23 number of helium atoms. So we are given the number of helium atoms. Na is the Avogadro number, and that is 6.022 into 10 to the power 23. The number of helium atoms given are 12.044 into 10 to the power 23, and we want to find out the number of moles. So we can write number of moles of helium atom is equal to, for that we need to divide the number of species or number of atoms with Na. So that is number of atoms divided by the Avogadro number. Number of atoms is 12.044 into 10 to the power 23 divided by 6.022 into 10 to the power 23. For 12.044 into 10 to the power 23, we can write 2 multiplied by 6.022 into 10 to the power 23 divided by 6.022 into 10 to the power 23. Finally, we get the answer 2 by dividing 6.022 and 6.022. We get answer 1, and that is 2 moles of helium atom we get as an answer. बच्चों, अगर आपको कुछ समझ में नहीं आ रहा है तो आप बिल्कुल मुझे बीच में ही रोक के पूछ सकते हैं. यू कैन आस्क मी योर डाउट्स. सब समझ में आ रहा है बच्चों? कुछ समझ में नहीं आ रहा तो पूछिए प्लीज. Okay, now we want to calculate mass from the numbers. So my dear students, we want to calculate mass from the number. So this is mass. We want to calculate from the number. So from number, first we need to go to the number of moles, and from number of moles, by multiplying them with the proper number, we will get mass in gram. Here, as it is given n atoms, so first the nitrogen atoms has to be multiplied with the nitrogen atom has to be divided with the Avogadro number to get the number of moles, and this number of moles, if we will multiply with the atomic mass, we will get mass in gram. So first we need to take the number of atoms, then from number of atoms we need to go to number of moles, and then from number of moles we can go to the mass in gram. And therefore moles is equal to number of atoms divided by Avogadro number, that is 3.011 into 10 to the power 23 divided by 6.022 into 10 to the power 23. 6.022 is nothing but 3.0011 multiplied by 2, and thus we get 1 by 2 or 0.5 moles of nitrogen atom. Now mass in gram is equal to number of moles multiplied by atomic mass. Number of mole is 1 by 2 and atomic mass is 14 gram per mole. So by doing this calculation, we get 7 gram of nitrogen atoms. If we have 3.011 into 10 to the power 23 number of nitrogen atoms, this number of nitrogen atom weighs 7 gram. Now let us understand the next question. The next question is calculating mass from the number. So it's the same kind of question, just instead of the nitrogen atom, here we take nitrogen molecules. So my dear students, when we need to take from number of molecules. So here we have number of molecules. From number of molecules, we will go for the number of moles. And from number of moles, we need to multiply with the molecular mass instead of the atomic mass. Because here in the question, they gave us nitrogen atom. Here they gave us the nitrogen molecule. So instead of multiplying with the atomic mass, here we need to multiply them with the molecular mass. Let us understand. So here, to solve these questions, first from the number of moles, we need to calculate moles, and from these moles, we will calculate mass in gram. Therefore, moles is equal to number of moles divided by Avogadro number. Here both the number of mole is 6.022 into 10 to the power 23. Avogadro number is even 6.022 into 10 to the power 23. So nitrogen molecule are 1 mole of nitrogen molecules. For calculating this 1 mole nitrogen molecule with a molecular mass, first we need to calculate the molecular mass of nitrogen, molecular mass of N2, which is diatomic. Therefore, molecular mass of N2 is equal to 2 into atomic mass of nitrogen, that is 2 into 14, that is 28 gram per mole. Now mass in gram is equal to number of moles multiplied by molecular mass. Number of mole is 1, molecular mass is 28 gram per mole. So the mass in gram is 28 gram. So my dear students, 6.022 into 10 to the power 23 molecules of nitrogen gas weighs 28 gram. Now, my dear students, we want to calculate the number of particles. So, we want to calculate the number of particles. In first case, we want to calculate the number of particles from mass, and that is for atoms. So, again, we are given mass in gram. From mass in gram, we will go to the number of moles by dividing for atoms. We will divide it with the atomic mass, and then from the number of moles, we multiply it with the Avogadro number to get the number of atoms. So first we will take mass in gram. Mass in gram we will convert into the moles, and from moles we will convert it into the particles. So let us move and understand this calculation one by one. Here you can see that in this case the mass in moles is equal to mass in gram divided by atomic mass. Mass in gram is 46 gram, atomic mass is 23. So we have 2 moles of sodium atom. This 46 is given into the question itself, and at atomic mass of sodium is 23. That is what we are well aware. So 46 divided by 23, that gives us 2 moles. So 46 gram of sodium atom is actually equal to 2 moles of sodium atom. Now number of particles is equal to moles multiplied by the Avogadro number. Mole are 2. Avogadro number is 6.022 into 10 to the power 23, which simply gives us 12.044 into 10 to the power 23 particles. So this is how, my dear students, we solve the questions given to us. Now let's move to the next question. In the next question, they have given 8 gram of oxygen molecules. So instead of atoms, they have given us the molecules, and this is the kind of calculation where we find out number of molecules from the mass. So first we will find out the molecular mass of oxygen, that is 2 into atomic mass of oxygen, that is 2 into 16, because atomic mass of oxygen is 16, that is 32 gram per mole. Now as usual, my dear students, moles is equal to mass in gram divided by the molecular mass. Instead of atomic mass, here they are given molecule, so we will do the molecular mass. Molecular mass is 32 gram per mole. Mass in gram they have given, that is 8 gram of oxygen molecule. So 8 gram divided by 32 gram, that gives us the 1 by 4 mole or 0.25 moles. Now number of molecules is equal to number of moles multiplied by the Avogadro number, that is 1 by 4 multiplied by 6.022 into 10 to the power 23. When we divide 6.022 with 4, we get 1.505 into 10 to the power 23 molecules of oxygen or O2. So this is how, my dear students, we understand the various calculations. Now we have the next question to understand. We need to understand 0.1 mole of carbon atoms. They are number given from the moles. So moles has to be converted from the to the number of atoms. Number of atoms, if you want to convert it into the moles, so number of atoms, the moles needs to multiply with the Avogadro number. Here they have given us 0.1 mole. So 0.1 multiplied by 6.02 10 to the power 23. My dear students, this 0.1 is nothing but your 1 divided by 10. That is 1 divided by 10 to the power 1. 1 divided by 10 to the power 1. This is what we can write it as a 10 to the power minus 1, because this 10 to the power 1, when it comes from denominator to numerator, the power become minus. So for 0.1, we can write 10 to the power minus 1 multiplied by 6.022 into 10 to the power 23. That is 6.022 into 10 to the power 23 minus 1. And finally, we get 6.022 into 10 to the power 22 carbon atoms. So this is how, my dear students, we solve the various problems. Let's look at some other problems. Let's have a look to the next question. The next question tells us that, let us have a look to the next question. The next question tells us that if 1 mole of carbon atom weighs 12 gram, what is the mass in gram of 1 atom of carbon? So let us solve these questions in a very simple manner. 1 mole of carbon atom, that means 6.022 into 10 to the power 23 carbon atoms. Now 6.022 into 10 to the power 23 carbon atoms weighs 12 gram, because 1 mole of carbon atom weighs 12 gram. That means 6.022 into 10 to the power 23 carbon atoms actually weighs 12 gram. Therefore, one carbon atom weighs what? So one carbon atom actually weighs 1 divided by 6.022 into 10 to the 23. This divided by this multiplied by 12. And that is what we get answer as a 12 divided by 6.022 into 10 to the power 23, which is approximately 2 into 10 to the power 23 gram. Please remember that we have avoided this 0.22 for the simplification of the calculation, and that is why the answer what we get is an approximate answer. But it is easy for you to calculate this way the various problems. Now, my dear students, the next question tells us which has more number of atoms, whether 100 gram of sodium or 100 gram of iron. They have even given that atomic mass of sodium is 23U and atomic mass of iron is 56U. Now, for this, my dear students, first we need to convert the mass of gram into mole, and then from moles we can go to the number of atoms. So for sodium, the mass is 100 gram. For iron, the mass is 100 gram, and that is why the number of moles is equal to mass in atom, mass divided by atomic mass, that is 100 divided by 23 for sodium and 100 divided by 56 for iron. Now, my dear students, number of atoms is equal to moles multiplied by Avogadro number. So for sodium, the moles is 100 by 23, and for iron, the moles is 100 by 56. Both this number 100 divided by 23 and 100 divided by 56 are multiplied by 6.022 into 10 to the power 23. Now, my dear students, if we find the answer for 100 divided by 23, it is approximately between 3 to 4. The answer that we find for 100 divided by 23 is approximately between 3 to 4. And 100 divided by 56, it is approximately between 1 to 2. So the answer is approximately between 1 to 2. That means this answer 3 to 4 is more than the answer 1 to 2. That means we can say that 100 divided by 23 multiplied by 6.022 into 10 to the power 23 is more than 100 divided by 56 multiplied by 6.022 into 10 to the power 23. These are the number of atoms present in 100 gram of sodium and 100 gram of iron. And that is why we can easily say that 100 gram of sodium has more atoms as compared to the 100 gram of iron. So this is how, my dear students, it is very easy for us to calculate and solve such a problems having the knowledge of the with the knowledge of the mole concept. Now let us calculate a very important questions from your exercise. It says that calculate the number of aluminum ions present in 0.051 gram of aluminum oxide. So first we need to understand this aluminum oxide. So for that, let us understand the aluminum oxide in the proper manner. So for aluminum oxide, my dear students, we can write aluminum oxide has aluminum ion and oxide ion. So for aluminum ion, we can write Al plus 3, and for oxide ion, we can write O minus 2. Now we can just write charge. For aluminum, the charge is 3. This is what we write it charge here. So the charge for aluminum is actually 3 and the charge on oxygen is actually 2. Then we take the LCM. So LCM between 3 and 2 is 6. So we draw a line and write 6 bit under the line, and then we try to multiply with the proper number so that we can find out the number of ions required to make the aluminum oxide. We by 3 if multiplied by 2 gives us 6. 2 if multiplied by 3 gives us 6, and that is why we can say that we need 2 aluminum plus 3 ion and 3 O minus 2 ion in the formula of aluminum oxide. So my dear students, from here itself you understand that in aluminum oxide, we have 2 aluminum plus 3 ion and 3 O minus 2 ion. It is necessary for you to understand this before you solve this question, and that is why I have made this effort to let you know that one aluminum oxide has 2 aluminum plus 3 ion and 3 O minus 2 ion. So that is what I have even written here, that aluminum oxide has one aluminum oxide has 2 aluminum plus 3 ion and 3 O minus 2 iron. Now by knowing this, let us calculate the question, or let us solve the answer. Now, to understand this, even it is necessary that you calculate the molecular mass of Al2O3. So, molecular mass of Al2O3, that is 2 into the atomic mass of aluminum plus 3 into the atomic mass of oxygen. Atomic mass of aluminum is 27, so 2 into 27. Atomic mass of oxygen is 16, so 3 into 16. That gives us the 54 plus 48, which cumulatively gives us the molecular mass of Al2O3 is 102 gram per mole. It means 1 mole of Al2O3 is equal to 102 gram per mole. But we are well aware that 1 mole is equal to 6.022 into 10 to the power 23. Therefore, 1 mole of Al2O3 is equal to 6.022 into 10 to the power 23 Al2O3. This is even very easy for us to understand, my dear students. So let us, we have understood this. Now let's move forward and calculate the rest of the calculation. 102 gram of Al2O3 is equal to 6.022 into 10 to the power 23 Al2O3. Therefore, 0.50 gram of Al2O3 is equal to 0.51 divided by 102 multiplied by 6.022 into 10 to the power 23 Al2O3. We do not simplify this, my dear students, and we move forward. We have seen that one Al2O3 has 2 Al plus 3 ion, and that is why 0.51 divided by 102 multiplied by 6.022 into 10 to the power 23 Al2 has how many ions? How many Al plus 3 ions? So we can here calculate the Al plus 3 ion is equal to 0.51 multiplied by 6.022 into 10 to the power 23 divided by 100 multiplied by 2, because each Al2O3 has 2 Al plus 3 ion. And finally, by doing this calculation, for 102 we can write 51 multiplied by 2. For 0.51 we write 51 divided by 100, and for 6.022 and 2 we put as usual. And by doing these calculations, by cancelling or by dividing 51 with 51 and 2 with 2, we find 1 divided by 100 into 6.022 into 10 to the power 23. 1 divided by 100 is 10 to the power minus 2. And finally, we get answer as 6.022 into 10 to the power 23 minus 2, because 1 divided by 100 is 10 to the power minus 2 and powers are subtracted, and that is why the number of Al plus 3 ions that we get is 6.022 into 10 to the power 23 Al plus 3 ions. So this is how, my dear students, we solve the various problems from your exercises as well as from your in-text questions, and now it will be easy for you to understand all these terms.